Today our topic is solution. Solution is the mixture of substances where there are two or more substances can mix in a solution. In the solution, um, we we imagine there are two substances. One is solvent, another is solute. The solvent is the substance which has more amount, and the solvent is the substance which has less amount. Sometimes the amount cannot define what is the solvent and what is the solution. In that case, the state of the solution that corresponds with the substance, that is known as the solvent. Other one is the solute. In our biochemistry or in our clinical medicine, this solution and solvent is a very much related with our all the topics. So, for example, we have the fluid. This fluid remains within the cell and outside the cell. Intracellular fluid and the extracellular fluid. This intracellular fluid and extracellular fluid are not the only fluid. They are the solutions. They are the solution. If we see what is in the intracellular fluid and extracellular fluid, we can see here is a diagram, and in this diagram we can see that there is the intracellular fluid and here is the extracellular fluid. This extracellular fluid can be divided into the plasma and the interstitial fluid. This extracellular fluid and the intercellular fluid remains in a state of equilibrium. Here we can see that if we take the fluid through our stomach, they reach to the intestine. From here some fluid or some solutions will enter into this plasma, then it goes to the interstitial fluid and finally goes to the intracellular fluid. On the same thing happens, some fluid will leave the intracellular space to the interstitial space, then to the plasma and then to the intestine. This is a bilateral communication. All these fluids remains in a steady state. These fluids are the solution. Now we see the compartments here. Here is the total thing is the extracellular, and here is the intracellular fluid. Here we see that extracellular fluid is separated through the capillary into plasma and the interstitial fluid, and this extracellular fluid is separated from the intracellular fluid by the cell membrane. And interesting thing that these fluid are the solution. These fluid are the solution, but they have not the same thing in this solution. Here we can see that in this solution, we start with this thing. Here you can see this is the concentration, milli equivalent per liter. This is the unit of the solution. We will learn it later how the unit will be measured in the solution. Here we can see that 0 to 200. In this extracellular fluid, we can see that sodium ion concentration is more in above 100 in the extracellular fluid like plasma, and in the interstitial fluid it is also more this sodium ion concentration, but potassium ion concentration is less in the plasma as well as the interstitial fluid. But the opposite thing in the intracellular fluid. Here we can see the potassium ion concentration is more and sodium ion concentration is less. This is on difference with these two fluid compartments, and this is the difference in this solution. This solution has more sodium, this solution has more potassium, and this sodium has the chloride Here is more chloride, this extracellular fluid, but in the intracellular fluid there is less chloride. This is another thing, this solution has less chloride ion, this solution has more chloride ion. Another thing, that this interstitial fluid has very little protein, negligible protein. Here we can see no protein. Here is the protein, and here is a little bit more than this extracellular fluid, the protein ion. So here we can see that this interstitial fluid and extracellular fluid forms on type of solution where there is more sodium, more chloride and less potassium, and in the interstitial fluid there is protein. This is one component of the solution. There is another component of the solution where is more potassium and less sodium and chloride. These two solutions remain in a equilibrium through a semi-permeable membrane that is known as the cell membrane. So, in this connection, we have to learn the solution that has the sodium, potassium, sodium and chloride. These ions form a solution where we cannot see these ions within the solution. But if we have a solution with the protein, we can identify these protein particles within the solution through microscope or sometimes in the naked eye. This is the difference of two solutions. One solution has small ions that cannot be seen, that cannot be separated from the solution, that is the crystalloid solution, and one solution has protein or larger solutes in the solvent, that is known as the colloid solution. So in our body fluid, whether it is extracellular or the intracellular fluid, they are the complex form of the solution with the colloid colloid forming protein and the crystalloid with these small ions. So in this connection we have to learn what is colloid and what is crystalloid. So the solutions that has the smaller particle size and they dissolve in a solvent to form a solution, and the particles cannot be seen through the microscope, that is known as the crystalloid solution. In this crystalloid solution, the particle size is very much small. It might be less than 1 nanometer, and it cannot be seen through the microscope. This is the crystalloid solution. When we dissolve sodium chloride into the water, that form the solution, that is the crystalloid, and this particle size is very small, and the colloid is when there is the larger particle size forming the solution. The particle size might be the 1 nanometer to 100 nanometer, and these larger particles can be seen through the microscope. There are small particles, they are wandering here and there into the solution, that is known as the colloidal solution. If there are small particles that can be seen through the microscope, so there is a very random movement. This movement within the colloid, that is known as the Brownian movement. This Brownian movement is the properties of the colloid, as there are small particles that can be seen. And there is another thing, if we pass the light through this particle containing solution, that means the colloid solution, so light will enter through the solution, and they will be disturbed or they will be reflected through this particle size, and they can change the direction of the light, that is known as the Tyndall phenomenon. So that is the properties of the colloid solution. The light can change its direction, and if there are some particles within the solution and this particle may contain some electrical charge, so this is another properties of the colloid solution. And the colloid has very small particles. If we aggregate this particle in a area, they will have a larger surface area. There are different properties of the colloid solutions. You may ask in your exam, what are the properties of the colloid solutions? As we have many colloid solutions in our body, so these are the properties of the colloid solution. And if we want to learn what is the difference between the colloid and crystalloid, what is the difference? First difference is that if we separate these solutions through the semi-permeable membrane, we have the semi-permeable membrane in our cell, and colloid solutions are within the intracellular space and the extracellular spaces. So in that cases, when these solutions are separated through the semi-permeable membrane, the colloid particles cannot transfer from one side to the another side of the membrane, but crystalloid particle can transmit from this semi-permeable membrane. So this is one difference of the colloid and crystalloid. Another thing is the size, particle size. Particles is large in the colloid, and the particles that are remain within the crystalloid solution, there are small particle size. So the number of the particle size will be more in the crystalloid solution than the colloid solution. This number of the particle exert a pressure effect. As the crystalloid has more and more particle in the solution than the colloid, so crystalloid has exert more osmotic pressure than the colloid, but colloid has a little bit osmotic pressure with it, and it is calculated as colloidal osmotic pressure. And thing is that the crystalloid has more particles, so they has more ability to show the osmotic pressure, and crystalloid is the more osmotically active than the colloid, but colloid is also osmotically active, and we will learn the colloid osmotic pressure in our capillary circulation or the microcirculation. These are the things about the solutions, colloid, crystalloid. Now the dialysis. In our body we have seen that the solutions or extracellular fluid is a mixture of the colloid and crystalloid. So when we need to separate this thing from the colloid to the crystalloid, then we use a semi-permeable membrane through which the colloid substance cannot pass from one side to the another side, but crystalloid can pass. In our kidney disease, end-stage kidney disease, when there is less ability of the kidney to filter these things, then we use the artificial filtering activities known as the dialysis. Isotopes are the atoms who has the same atomic number but different atomic weight. You have learned it in your elementary sessions. This atomic weight is different as because they has the different number is neutron. So the atomic weight is different from the atomic number. That is the isotopes. There are different forms of isotopes. Some isotopes are stable isotopes, and some isotopes are unstable, and that means the radioactive isotope. And there are use of this radioactive isotope in our biology to trace the biochemical reactions. Sometimes in the treatment of disease, these are the radioactive isotopes. So our solutions, colloid, crystalloid, the dialysis, and the isotopes. Mole is the gram atomic weight of a substance. So for example, water has 2 hydrogen and 1 oxygen. Oxygen has the atomic weight of 16, and the hydrogen has atomic weight of 1. So the molecular weight of the water is the 16 plus 2, so 18. So 18 gram of water will be known as the 1 mole of water. That is the mole. So mole per liter, millimole per liter, And now the milli equivalent. Milli equivalent is the mole divided by the valency of that atom. So for example, if we have the sodium, sodium has the molecular weight of 35 like that, and it has the valency of 1. So the equivalent of sodium ion concentration will be molecular weight divided by its valency 1. So it will same as the molecular weight. That is the milli equivalent. And when this amount of sodium will dissolve in the 1 liter of water, that is known as the milli equivalent per liter. When 1000 parts of the equivalent weight, that is the milli equivalent per liter. It is the concentration that is used in our physiological fluid.